Now in the last example, in the last video, we saw something kind of interesting pop out at the end. I had this truth table set up for a biconditional statement that was a combination of a disjunction and a conditional. And so we found out in the end that the 4 truth values are equivalent to the 4 truth values of not P in that column. And so that leads us into the next topic here on equivalent statements. By definition, two statements, two compound statements specifically, are going to be equivalent if all of their truth values are the same in a truth table all the way down, okay? So we would say that two statements are equivalent, and I probably should input here that they're compound statements, but this will work for now. Two statements are equivalent when all truth values, that could be T or F, are the same in the truth table for the same set of simple statements. Okay, now it could be the case you had a different set of simple statements. Maybe I had PQR and something changes. I don't know that that's really, well, yeah, if you had PQR in one table and PQ in the other table, then you know your columns will look different because one has more rows than the other or something. So just in general, you gotta have the same simple statements. But as long as these columns match up, and here they're false, false, true, true, then we say that the statements are equivalent, okay? Now in this particular case, I could say that not P or Q, if and only if then, or if P then not Q is equivalent. And with equivalent logical statements or logic statements, we use a 3-bar equal sign. It kind of looks like an equal sign but with 3 bars in it. That's equivalent to simply not P. All right, so these are equivalent statements. In fact, they could just be, one could just replace the other and that would be valid. So instead of having this very lengthy expression here, a very lengthy sentence, which, if I knew what P and Q were, I could form the sentence, but it would be long, right? It's quite a long sentence, but it's the same as just not P. So you could just substitute in not P and have the same basic meaning and have it apply the same. So kind of interesting that is the definition of equivalent statements. And again, I should probably put in compound statements to make that make sense, because here I've got to separate off the simple statements, the parts of them. You have to say that the same parts occur. Okay, so that gets us a quick definition. Now we'll look at some examples, proving things to be either equivalent or verifying that they're not.